All right, so the very first thing we're going to talk about is make sure that you're filling out all the information in the top. Make sure you put your name, the date, and the block. Okay? So take a look at these and try to guess for yourself, and then we're going to go over them. So check these answers. So radius is the general size of the atom. Electronegativity measures basically how much of a thief that element's going to be, how likely it is to steal electrons from another. Ionization energy is much like a doomsday prepper. It's very protected. Elements that have a high ionization energy it's going to be more difficult to steal their electrons than elements that have a low ionization energy. So it's almost like protectiveness. So how protected they are of their electrons, the thief of electrons, size of electrons, and the electron affinity, it increases with it has the same trend as the other three. And that's how we're going to talk about that for right now, okay? So we're going to list the highest in each category. So the element that has the highest atomic radius is for a couple reasons if you watched the video before. So just in conclusion, we're going to do atomic radius. The largest element is going to be the one that has the most rings on a Bohr model. If we were looking at it, I like to talk about these in terms of a Bohr model. So since elements at the bottom of the periodic table have more rings, then they tend to be larger. So the atomic trend tends to increase for radius as you go down the periodic table. The trend goes smaller as you go across. Now you got to remember why. What if I told you the nucleus was like a magnet, a very strong magnet? And the more protons you put in the middle of that nucleus, and protons tell you what person it is. So as you jump from left to right and go from element to element, the farther right you go, the more protons you have in that nucleus. The stronger that magnet is. Now, what charge do they have? Positive, right? So what are they attracting to them? Negative charges. And what subatomic particle do we have that's negatively charged? The electrons. So the electrons are much, much smaller than protons. So even though we're going left to right, we're adding a proton and electron. A proton is exponentially larger than an electron. So you have an exponentially stronger nucleus pulling on those electrons. And so as you go left to right, it's actually pulling the electrons tighter and tighter to itself. And it's becoming more and more condensed and more dense. Correct? So elements on the right side of the periodic table are smaller than those on the left, even though they have more pieces in them because they're more compact. Does that make sense? All right. So what element is going to be the biggest? One on the right or the left? The left. And then we've determined that the more rings on the Bohr model we would have had, the bigger it would be. So we want something on the bottom left. What element is the farthest bottom left? It is francium, Fr. By polar opposite, the element that has the fewest rows, and the element that has, because the fewer rings on that Bohr model, the easier it is for that nucleus to reach and steal and grab other electrons. So the fewer rings it has, the stronger it is to steal, right? And the smaller it is, the easier it is for it to maneuver and get around and take electrons also. So ionization energy is going to be helium. He's the most protected. He's the most protected also because he's a noble gas. Noble gases are full. They don't want to trade with anybody. Electronegativity. These are the thieves, right? So the highest in electronegativity is why? Well, he's very small, but he's not full. He's very hungry. Everything in that column, noble gases, is the very far right. It starts with helium, neon, argon, krypton, xenon, radon, all those. All those are noble gases, and the column next to it, fluorine, chlorine, bromine, iodine, all those just need one more to be satisfied. So they're really hungry for electrons. So all of those that are halogens that are right next to the noble gases, those are they tend to have high electronegativities. Chlorine has the highest electron affinity. And we'll talk a little bit more in depth on that. So what we're going to do for these is we're going to look at atomic radius. So francium is the highest atomic radius. So it's at the bottom and on the left side of that chart. So elements that are more left or more down below or toward the bottom tend to have higher atomic radius. Now notice that this says increases and decreases. So if I look here and they ask you about decreasing atomic radius, it would go in the opposite direction. This would it would get smaller as we go up and to the right. Now, let's look at another element. Electronegativity, we said, was fluorine. And that's on the top and toward the right. Good. So any element that's more toward the right or more toward the top is going to automatically be the element that is more electronegative. And conversely, the decreasing electronegativity would be the opposite. It would be further down, further left, or further away from that element that we've circled. And the increasing is to them, okay? We're going to do the same thing over here for ionization energy. The hardest person to steal from is helium, and he's at the top and the right. And conversely, for electron affinity, it would be chlorine, so top, right. And ionization energy would be the opposite, so it would be down, left, down, left. And just as a broad overview, there's only one trend that goes in an opposite direction, and that is atomic radius. The other three tend to be all in the same direction. So just a little point of note to help you remember what direction everything goes. These are the ones that go opposite directions.